Hey guys, in this video we're going to be moving on to lesson 5.3, which is over the next two triangle congruencies, so ASA and AAS. So for ASA, we can say that two triangles are congruent if two angles and the included side are congruent. And you may ask, what is the included side? It is the side that runs between the two angles. So wherever our two angles are that are congruent, we want the side that's connecting them. So for example, let's say these two angles are congruent. These two angles are congruent. So those would be two angles. Now the included side would be this side that goes between them, that connects them. So if we have that information, that is enough to say that those two triangles are congruent. Next, we have AAS. So this is if we have two angles and a non-included side. Are congruent. So we have two angles and then a third side, one that's not.
Anyone in the building that knows anything about the ACT Saturday, will you please call the office regarding a student?
Sorry about that, if you heard that. All right, so let's say this angle is congruent to this angle, and this one is congruent to this one. And then let's say that this side is congruent to that side. That would be AAS, two angles and then a third side. So let's look at some examples, and some of these are going to be a little more difficult maybe than what we saw the last time. You're going to have to pull in some previous knowledge of parallel lines and that sort of thing. So it tells us that YZ bisects angle WYX. So here's angle WYX, and since YZ bisects it, that means that this angle and this angle are congruent. Now it also tells us that angle YWZ is congruent to YXZ. Something else that you should note is that they share this side. So anytime you have triangles that share a side, then we can mark that one as being congruent. So this one, we have two angles, but the side that's marked is not included. So that one would be AAS. And we also want to write a congruency statement. So triangle, let's just start at YZW is congruent to triangle YZX. And when you write these out, double check to make sure. So I've got angle W and angle X should be in the same spot because they're the same, they're congruent. Angle Y and angle Y should be in the same spot. So it does look like I have it correct. Number 2, we've got some parallel lines. So let's start with JK is parallel to JM, and then this would be my transversal. So what helps us here is that we have alternate interior angles, and alternate interior angles are congruent. And so that would mean that these right here are also congruent. And we know that they share a side. So we didn't really even have to use J, L, and KM. We got everything we needed to say that this one is angle, side, angle, because we have the two angles, and the side that's congruent is the one connecting the two angles. It runs here. So the harder part is our congruent statement. So I'm going to think about, okay, it's easy to go based on your angles. So triangle KLJ
Mr. Jesse Mahaffey, call the office, please.
is congruent to triangle. Well, angle K was the one that was pink. So in my other triangle, the one that's pink is L. And then, let's see, in my first triangle, over here, L is green, so it's congruent to K. So basically, I went pink, green, blank. Pink, green, blank. So LKM. It also might help to kind of, that is terribly drawn, but you get the point. Whoops. Sometimes it does help to draw them out separately to see which ones match up. All right, number 3, angle ABC is congruent to angle CED. AB is parallel to CE. So the transversal that runs through both triangles is this line down here. So if I try to do like alternate interior angles, I'm going to have some angles that are not in my triangle. But what I do have are corresponding angles. So those angles are congruent. And then it tells us that C is the midpoint of AD. So that means that this one and this one are congruent. So we have two angles and a non-included side. So that side is not running between the two angles. So it would be AAS. So let's see, triangle ABC is congruent to triangle. I went green, pink, blank. So green, pink, blank would be CED. All right, number 4. One thing I noticed right off the bat is that we have vertical angles. I didn't even read any of my information first. Then it tells us that BAC angle is congruent to angle DEC. And it tells us that C is the midpoint of AE. So this one and this one are congruent. So we have two angles and the side that runs between them. So angle, side, angle. And that means triangle ABC is congruent to triangle. Okay, I went purple, blank, blue. So purple, blank, blue on the other triangle would be EDC. Number 5, SQ bisects angle RQT. So this angle and that angle are the same. And SQ also bisects RST. So this angle and this angle is the same. And they share the side in the middle. So we have two angles and the side that runs between them. ASA. So if I write out my congruent statement, RSQ is congruent. I went blank, green, pink. So on the other triangle, blank would be TSQ. And last one, number 6. PR bisects QRS. So this one and this one's the same. PSR, angle PSR, is congruent to angle PQR. And they share a side. So this time I have 2 angles, but the side is not running between the angles. It's a non-included side. So it would be AAS. And triangle PQR is congruent to triangle. I went blank, green, pink. So blank, green, pink would be triangle PSR. I know that's a little confusing. The congruent statements is, I think, the most confusing. So if you need help with that, or you just need me to show you, if you're in class, you need me to show you, please ask. And I don't mind at all to help you. Have a great day.